And the value that's inside the bracket that's being added or subtracted is my d value. And the value inside the bracket that's being multiplied is my k value. So that's pretty straightforward. The only thing is my d value is the opposite sign, so it's actually positive 3. Whereas the rest are all as is. So don't forget that. The first thing I'm going to do is I'm going to rewrite this as an equation because some questions may ask you to do that. You don't have to do that if the question doesn't ask you, but some questions will ask you to rewrite this notation into an equation. How would you do that? Or what does that mean? Well, basically that just means that instead of writing f of x, I want you to write the actual function. So -4 square root bracket -2 bracket x minus 3 close bracket plus 1. So this is how you write it as an equation. Because in function notation, we really can't graph this because we don't know what the parent function is. If you look at the original function, look at the original function, see how it's written. F, like -4f bracket -2 bracket x minus 3 close bracket plus 1. Nowhere in there does it actually show us what the parent function is. Is the parent function x squared? Is the parent function square root x? Is the parent function 1 over x? We don't know. There's also absolute value x, but we haven't talked about any of those yet. You'll have to go through the notes. So it doesn't say, but we know because the question I don't have it here, but question states, state the transformations for the parent function square root x. So since the parent function is square root x, I'm going to now rewrite the equation to show the square root symbol. And this is how you show it, this is how you write it. And now I write my a value. My a value is -4. My k value is -2. My d value is +3, and my c value is +1. I should probably sort of reverse that, just because a and c are the y coordinates and k and d are the x coordinates. All right, so what do? First things first, I describe these transformations using words. What does it mean to describe transformations? Easy, I'll show you. So this function has been vertically transformed, has a vertical stretch by a factor of 4. So you have to write all these words. You can't skip any of these, so you know. So vertical stretch by a factor of 4, why? How do I know? Remember, a is my vertical stretch, and if a is bigger than 1, or the number value, it's a stretch. But that negative sign, we know that negative sign means it's a vertical reflection along the x-axis. We know that the negative value for a means that there's also a reflection. All right, so a is done. We got the stretch, we got the reflection. Now we're down to k. Remember, k is horizontal, so horizontal. Now, is this a horizontal reflection or stretch? Sorry, I apologize. Is it horizontal stretch or compression? Well, k value is -2. If you go back to our notes. Oh, I deleted the notes. Sadness. So if k value is, what was k value? 2. Remember, the negative just means it's reflection. You're just looking at the numerical value. So if k value is 2, it's this top word here. It's compressed horizontally by a factor of 1 over k. So that's important. So this is a horizontal compression by a factor of 1 over 2. You don't put the negative. Remember, the negative just means that it's a reflection. That's all that the negative means. So this is a horizontal reflection along the y-axis. All right, k value is done. We got our horizontal compression. We got our reflection. D value. So this is for this you can write shift right by 3 units. You don't have to write horizontal translation by 3 units. That's fine. Shift right by 3 units. That's good enough for D value. And C value is the same thing. Shift up by 1 unit. So you got the direction and you got the how many spaces. And that is how you describe transformations. And this is how you describe transformations for every single different parent function. It doesn't matter if your parent function is y equals x squared. This wording would be exactly the same. It doesn't matter if your parent function is y equals 1 over x. Because if your a value is these values, the transformations are always these. What's different is your table of values when you graph, because the graph will look different. But the description of transformations, they don't change. Okay, so now that we've described the transformations, what's next? We need to actually graph. We need to graph this this function g of x, and the only way to graph is to first make a table of values. So let's steal some table of values, shall we? All right, got a nice little table of values here now for us to work with. I don't really care if I cover the transformations because you guys can take a look at that yourself later. Okay. So parent function, what's our parent function? Y equals square root x, or f of x is equal to. That's my parent function. You will learn in the notes that each parent function has certain key points that you need to memorize, or you need to write down on a formula sheet, or you need to have like some kind of tactic to memorize these values. So for square root x, the values are 0, 1, 4, and 9. And the next one would have been 16, and so on. Why are these numbers chosen? Because these numbers are perfect squares. Because the function is square root x. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. We don't like, decimal values. When we're graphing, we want kind of like whole numbers, right? And if we can get whole numbers, why not? Now, sometimes it's impossible. You need to have fractions and decimals, which is fine. But for the parent function, you can always make your life easier by choosing values that work. Okay, so these are my key points. Now I'm going to do something called mapping notation. This is very important. You need to know mapping notation. Mapping notation is AY plus C X over K plus D. So that is mapping notation. And how do I use this? Well, remember your X value is on the left, Y value is here. So if my X over K, I actually swapped them. Whoops. Sorry guys, that was my mistake. X always comes first. Y always comes second. I apologize for that. All right, so X and Y, right? So X over K plus D, what's my K value? -2. So my equation is going to be X over -2. What's my D value? 3, so plus 3. That's my equation on this side. And my equation for AY plus C, well, A value is -4 times Y. C value is 1, so plus 1. So all you have to do now is take the original values from your parent function, substitute them into your mapping notation, and then spit out the corresponding result. So 0 plugs into x. What's 0 divided by -2? Obviously 0. What's 0 plus 3? 3. So my first value is going to be 3, my first x value. My next x value, well, if I substitute 1 into here, 1 divided by -2. What is the 1 divided by -2? Obviously -0.5. What's -0.5 plus 3? That is 2.5. Next value, 4. Substitute 4 into x. What's 4 divided by -2? Well, 4 divided by -2 is 4 divided by 2 is 2, and the negative is -2. -2 plus 3 is +1. All right. What about 9? Well, what's 9 divided by -2? Well, 9 divided by -2 is -4.5. -4.5 plus 3 is -1.5. So these are my x values. What about my y values? Well, I plug in my y values into my mapping notation for y. So 0 goes into y. 0 times 4 is 0 plus 1. It's 1. 1 goes into y. What's -4 times 1? Obviously -4. Negative 4 plus 1 is negative